All right, one way to describe a function is by a formula. So for instance, f of x equals x squared. Another way to describe a function is by a graph, by a picture. So first of all, let's just look at the function we were given by formula, f of x equals x squared. What is the graph? To get the graph, you should replace f of x with y. So we've got f of x equals x squared up at the top. Replace the f of x with a y, so you have y equals x squared. And that, y equals x squared, is an equation in x and y. We've talked before about equations in x and y, and those things have a graph, so you'd graph that. So just as another quick example, what is the graph of f of x equals 2x plus 3? Well, replace the f of x with a y, so we're talking about y equals 2x plus 3. So that's an equation in x and y, and you should graph that. We know from its format, y equals mx plus b, that that graph would be a line. In general, what you do is you replace f of x with a y, and then you have an equation in x and y, and then you'd graph that. So recall that xy is on the graph if xy satisfies the equation, and xy is not on the graph if that point xy does not satisfy the equation. So how do we graph something like f of x equals x squared anyway? Well, we just need to replace the f of x with a y, so we just need to graph y equals x squared. When starting, the way to do this, if you feel stuck, is to make a chart of x and y values. However, please note that this cannot be the only method you use to graph a function. So eventually you need to not rely on this method. So here for instance, is a chart of some x and y values. When you plug in x is 3, you get y is 9. When you plug in x is 2, you get y is 4, and so on and so forth. And if you plot, for instance, 3, 9, that's a point. 2, 4, that's a point. If you plot these points carefully, they're all going to be in the shape of a parabola, and we are going to click to just have the computer draw that parabola for us accurately. So you'll see here our graph of y equals x squared shown in red. A number of the points that were inside our chart of values are shown here, like 3, 9, 2, 4, and so on. Also, what I had the computer do was look at graphing f of x equals x squared. That should be the same. So we'll turn that on, and that's in blue, and that's why now the parabola here looks kind of purple, because it's a mix of this red and the blue. In fact, I could turn off the red and then turn on this blue. So these are occupying the same space here. Okay, so how is a function then related to its graph? So we've talked about how an equation in x and y is related to its graph. But because we're just replacing the f of x with a y, we can actually now answer more to the point. How is a function related to its graph? So the point a comma b is on the graph of a function f, if and only if f of a is equal to b. So we saw just a moment ago that 3, 9 is a point on the graph of f of x equals x squared. This is in fact because f of 3 equals 9. So either we say that 3, 9 is on the graph because f of 3 equals 9, or we say f of 3 equals 9 because 3, 9 is on the graph. Either way. Yeah? So we saw that 2, 4 is on the graph. The point 2, 4 is on the graph. And in fact, f of 2 is equal to 4. So let's find 3 points on the graph of f of x equals 2x plus 3. So, well, if we plug in 4 for x, we'll have f of 4 is equal to 11. So the point 4, 11 is on the graph. F of 10 is equal to 23. So the point 10, 23 is on the graph. F of 100 is equal to 203. So the point 100, 203 is on the graph. So those are 3 points. There's many more. Again, let's exercise this idea of the point a comma b is on the graph if and only if f of a is equal to b. And let's connect this to what we had said a moment earlier is the 3-part definition of a function. Specifically, I'd like to look at that third part, is a rule that provides exactly one output for each input. That third thing, if we just state it differently, says per input. There's only one output. And so there's this thing called the vertical line test, and a graph passes the vertical line test if every vertical line intersects the graph at most once. So a vertical line, wherever you draw it, should touch the graph once or fewer, meaning not at all. It's just a vertical line that's just drawn somewhere that just doesn't touch the graph. So why does the graph of every function pass the vertical line test? Well, it's because a function provides exactly one output for each input. So if you get just one output for each input, hey, for that input, like one input at a time, that value of input, which is the x coordinate, right? A is you just get one point, drawn at one height, whatever the output is called b. And then you don't get another output for that input. To get another output, you've got to go to a different input. And so that's why the graph of every function passes the vertical line test. Okay, so the graph of a function must pass the vertical line test. If we looked at this equation, x minus 3 quantity squared plus y minus 4 quantity squared equals 5, that's a circle. And so a circle, if you draw that, right, draw a circle, it's not going to pass the vertical line test. And so this is not the graph of a function. However, the graph of the function f of x equals x squared, we saw that was the same as the graph of y equals x squared. And that's a parabola that happened to pass the vertical line test. If we looked at the graph of the function f of x equals 2x plus 3, that's the same as the graph of y equals 2x plus 3. And we recognize that as a y equals mx plus b. That's a line which happens to pass the vertical line test as well. So the graph of every function must pass the vertical line test. This slide so far is showing you, in the first item, it's talking about a picture that doesn't pass the vertical line test. And then for the second and third items, these are both functions that do where the picture does pass the vertical line test.